Hey everybody, it's Mr. Longo, and in this video we are going to cover logarithm graphs. And important to remember parent functions for logs is they have a vertical asymptote at x equals 0 and a point at 1, 0, and y, you're probably wondering. And we're going to go talk about that this time. So, important to remember, what is log of, say, 8? Well, if you type that in your calculator, it's going to be 0.9. What is log of 0? And it is an error. Or that's what your calculator is going to tell you. There is no answer, and it's because you cannot take the log of a 0. You can also not take the log of a -5 either. So you can only take logs of positive numbers. Think about it. Like 0 raised to any number is still going to be 0. It's not going to do anything. So that is why x is going to have to be, or whatever you're taking a log of is going to have to be a positive number. That's why our vertical asymptote says x has to be equal to 0, which means it will never be 0. It can only be bigger, which is why our domain is x is greater than 0 now. And our point is 1, 0. And the reason why is because, remember, anything raised to the 0 power is 1. So logarithm graphs and exponential graphs, remember, they're just inverses of one another. If we graph the two of those together on the exact same one, they would be reflected over the y equals x line. They are inverses. So you'll also notice the domain and range switched in comparison to the exponential functions video we already had. So in exponential functions, domain was all real numbers, but range was y is greater than 0. Notice these two just switched. Okay, same with this. In an exponential graph, it was 0, 1, because anything raised to 0 was 1. Well, if you think about it in logs, it goes backwards, so it's 1, 0. Okay, so now we're just going to use transformations and the given vertical asymptote and point to figure out what we're going to do next. Okay, so transformations, remember, you work inside first. Inside we have x minus 4, so that means we're going to go right 4. And we're going to vertically stretch or vertically expand by 2. And then the last thing is up 1. So that's going to have an effect on a few things here. Right 4. That means our vertical asymptote, remember, it was at y, or x equals 0, so we're going right 1, 2, 3, 4. We have a vertical asymptote at x equals 4, which means our domain is going to be x is greater than 4. Our point started out at 1, 0. We went to the right 4. So now that became 5, 0. Then we vertically expanded by 2. That means we multiplied the y value by 2. 0 times 2 is still 0. So we're still here. And then finally up 1. So that adds 1 to y. So we are now at 5, 1. So right about here, 5, 1, that's the point we're going to hit. This was not reflected over the x-axis at all, so it's going to just look like it was before. We just had to move it over to the right and up a little bit. And of course your range is going to still be all real numbers. And that's it for that guy. We're just using transformations. Now again, remember, if you're allowed to use your graphing calculator for this, you can double check it all. It's going to be all good. But it's important to know why these graphs are taking the shapes that they are. Okay? So last example for this one, work inside first. There is no inside. Remember, if it's just x by itself right afterwards and the plus 2 is on the same level, that plus 2 is for the up and down at the end. Inside would be wrapped in parentheses, so nothing has happened to the inside. So now we just work left to right on the outside, and the first thing that happened is we reflected over the x-axis, which is going to change y values maybe, and then we are going up 2. So our vertical asymptote this time. Vertical asymptote, if we reflect, does nothing. Shifting it up 2 does nothing because vertical asymptote is x equals, so nothing happened to the x. So it's still x equals 0, which means your domain is x is going to be greater than 0. Okay, so now the point. The point was at 1, 0, and then we reflected over the x-axis. Remember, if you reflect over x, the x stays the same, y changes. You can't reflect 0 over anything, so it's still 1, 0. And then we shifted up 2. So our point became 1, 2. So we've got our x equals 0, vertical asymptote. We have our point 1, 2, which would be approximately right there. And the last thing you have to think about, though, is this was reflected over the x-axis. That means it's now starting high and finishing low. And of course, range is still going to be all real numbers because we can get any type of answer when we're doing it. You just can't plug in a 0 or a negative to x this time. Now again, if you compare this to the exponential function graph video, you'll notice that almost everything is opposite. We have vertical asymptotes instead of horizontal. Our point is 1, 0 instead of 0, 1. Our domain and ranges have switched, and that's because exponential functions and logarithmic functions are inverses of one another. All right, that's it for this video. This is Longo, and I'm out. See you, bye.